Hello everyone. This video is a bit different from my usual 6502 based videos. But if you like my other videos, I'm sure you'll like this too. This is a motherboard from an IBM PC XT model 5160, and it comes with an Intel 8088 CPU made by AMD. And even though the PC XT was already released by that time, this motherboard has a date code that tells us it was assembled in the 47th week of 1984. Since I bought it cheap and untested, I have to assume it's probably defective in one way or another, so I'll start by checking all the power lines for shorts and hopefully we won't find any. But if something's wrong, I'm sure we can fix it. I start by putting my multimeter into continuity mode and connect the common lead to one of the ground pins in the middle. The first line is the power good signal, then comes a key pin that should be unconnected on this board, then plus 12 volts and then the minus 12 volt rail. Sadly, it does look like there's a short on the minus 12 volt rail, but I'm sure we can fix that later. Next are the 4 ground lines, followed by the 5 volt lines, and those are allowed to have a resistance from a few hundred ohms to a few thousand ohms, which might differ from meter to meter. Luckily, the minus 12 volt rail isn't actually connected to anything other than the expansion slots and 2 capacitors. And probably it's one of those causing the problem. Since I've heard these old tantalum capacitors have a tendency to go bad over the years, I'll take a chance and snib a leg on that one. That did in fact make the short go away, and the nearest short is the ground rail itself. Before I try to connect power, I'll make sure the jumpers are in the correct position. The first switch activates continuous power on self-test, which we want to be off. The second switch deactivates the 8087 coprocessor, so that's on since we don't have one. The third and fourth switch are both set to off because all RAM banks are enabled. The fifth and sixth are set to off to test for a monochrome graphics card, and I set switch 7 and 8 on to indicate a single floppy drive, since that's the minimum. Since there are no LEDs or other indicators on the motherboard, we need to connect a speaker to pin 1 and 4 of the PC speaker connector. Since there are no power rail shorts and we have a speaker connected, we can move on to connecting power. The ATX to XT power adapter I'm using here doesn't seem to be keyed the right way, so I'm having a bit of trouble getting it in place. But I see the wire colors match up with the signals, so I'm sure it's supposed to connect this way. I guess I'll fix the keying later. Since I'm a little bit worried more of the old tantalum capacitors are bad, and they have a tendency to explode, I'll look away while I flip the power switch. Let's hope we don't let any magic smoke out. Okay, that did absolutely nothing. The power supply fan is spinning, but the speaker is completely silent. I guess it's a good sign that nothing exploded in my face and I don't smell anything burning. First, I'll check if anything seems extra hot. At least some of the ICs should start getting a little bit warmer, but nothing should be too hot to touch. Nothing's really too hot, but nothing is warming up either. It's kind of a long shot, but I'll try connecting an old hard drive to the power supply. At least that'll give me another indicator if it's good or not. The clicking noise from the hard drive isn't exactly good news about the disk itself, but at least it tells us the power supply can handle a bit of current and the board is probably getting enough juice. I guess it's time to make sure the board actually has 12 volts and 5 volts in the right places. And I guess the easiest places to test are the legs of the capacitors. It looks like there's power in the right places, so I'm starting to get a little bit worried about this board. My multimeter also has frequency mode, so I guess we can test if the crystal is oscillating before we bring out the big guns. I'll just connect one lead to ground and the other lead to one leg of the crystal. That should give us an indication if it's running. Since it does show 14.31 MHz, that's a good sign, but it doesn't really give us any indication why the speaker stays silent. I know -0degrees.net has a good troubleshooting guide, so I guess I'll have a look before I move forward. After going through the minimum diagnostic configuration page, I ended up on the faulty motherboard page. I know my power supply doesn't actually supply -5 volts, but since the RAM in the 5160 doesn't use it, that shouldn't be a problem until I plug in a card that needs -5 volts. I don't have a replacement BIOS on hand, so I'll move on and check a few more signals before I go down that path. Since I know the crystal is running at 14.3 MHz, we'll check the clock generator IC, the 8284A. Since that divides the 14.3 MHz clock by 3, we should see 4.77 MHz on pin 8. That seems to output the right clock as well, so we can check that it actually reaches pin 19 of the 8088 CPU and pin 2 of the 8288 bus controller. Going back to the faulty motherboard guide, the suggestion is to check pin 13 on the 8253 IC, which is the out 1 pin of the programmable interval timer. I'm not a PC expert, but as far as I can tell from the technical reference and the internet, this is the DMA request line 0, which initiates a dummy DMA request to refresh DRAM, which must happen periodically to preserve RAM data. Since I'm not sure what this pulse is supposed to look like, or if it even has a stable period, I think it's time to bring out the scope. So, if I can get the scope connected without shorting the pin next to it, we can take a look to see if there's any output on the pin. Since the pin just goes high when I turn on the power and no DMA pulses show up, I think we can start assuming something is off with one or both BIOS ROMs, designator U18 and U19. Luckily, I have a TL8662 ROM programmer that should let me read out the BIOS ROM, but first let's see if I can pull them out safely with my trusty dip removal tool. Okay, no broken plastic, so let's see if I can read U18 first. I use MiniPro to read the ROM, but I don't think it knows the model number of this ROM, so I'll just use a generic 32K ROM that should have the same pinout. My idea here is that if it's a good working ROM, I should be able to recognize some x86 assembly code and maybe some strings as ASCII text. I just use XXD to read the file as hex and ASCII and output to terminal. Okay, so this really doesn't look anything like what it's supposed to look like. I say that because I see a lot of repetition and nothing that looks like x86 assembly and no ASCII strings at all. It could be that I'm not reading the ROM right or something like that, but I have to say this does look like a bad BIOS ROM. Let's have a look at U19 before we move on though. I'll just plug that into the programmer and then we can try reading it the same way. I'm not really sure if this is an 8K or a 32K ROM, but since it should have a similar pinout, I can probably read it this way anyway. Now this looks a lot more like what I'd expect from an IBM BIOS ROM. There's not a lot of repetition, and there's even some ASCII text and I guess some basic keywords. To me, this certainly looks like a working ROM, even though I can't be sure without a checksum. I managed to find the 5160 ROM files on 0 degrees, but I don't actually have any 32K ROMs. I have plenty of 28-pin EEPROMs, but they're 64K, so I'm not sure they'll work. But at least the pinout is similar enough that it can't really hurt. MiniPro will complain that it's not the right size EEPROM, so I'll suppress that with the -s argument, and then all I have to do is burn the new ROM. Considering U19 looked fine, we can just use that the way it is, together with our freshly new burnt ROM. So that didn't actually work. Of course, I did use the wrong size ROM, which probably means the CPU is trying to read the wrong half of the ROM, but I think I have a way around that. First, I'd like to make sure the programmable interval timer still isn't outputting pulses, like if my speaker was broken and the new ROM actually worked. So let's have a quick look on the scope just to make sure. Yeah, that still isn't working, so let's see if we can make a working ROM. Since the ROMs I have are twice as big as what we need, and it's probably just the highest address line that's got the wrong level, we can probably fix that by writing the same data to the chip twice, and then it won't matter if A15 is high instead of low. First, I'll use cat to copy the ROM to a new file, and if I repeat that command, it'll append the ROM to the end of the first copy. That way, we have a single file with two identical 32K BIOSes in it. Let's burn it and plug it in. And we have post. I almost thought we wouldn't get this far, but it actually looks like we have a working IBM PC XT motherboard. The long beep followed by two short beeps simply means that no graphics card is plugged in, so that's a really good sound. I threw away my last ISA graphics card about 20 years ago, so right now I'm waiting for another one to arrive in the mail. I also don't have a keyboard that'll work directly with an XT motherboard, but I don't think it'll be a big problem to make an active adapter that'll convert PS2 scan codes into something this board will understand. I'll make a new video in this series when I receive the graphics card and get a keyboard working. But since I don't have controllers for MFM hard drives or floppy drives, I will probably try a few tests using the built-in ROM version of IBM BASIC. I'm really excited to see what that looks like. If you'd like to see what you can do with just BASIC before then, I suggest you take a look at my other video about running Microsoft BASIC from 1977 on my single board computer. Soon, I will also release a video about the 6507 CPU used in the Atari 2600, and hopefully I can even make a computer out of it on a single breadboard. We'll see. In the future, I hope to use this PC motherboard to write some x86 assembly boot sector games and maybe design some brand new ISA expansion cards. We'll see about that too. For now, thanks for watching.